Let's go ahead and solve a couple exponential equations. On each of these, how we want to approach this is we want to try to rewrite it so we have the exact same base on both sides. And if we do, we're allowed to drop the bases down, and set the exponents equal to one another. So if you can get the same base on both sides, drop those bases, set the exponents equal. On the first one, what I want to do is probably aim for having 5 as my common base on both sides. So I already have 5 to a power on the left-hand side. On the right-hand side, we can rewrite the 25 as 5 squared. Now that's still raised to the 3x plus 2 power because we've just rewritten the 25 as something equivalent with the base that we want. Next, what I'm going to go ahead and do is on the right-hand side, distribute that 2, multiply that 2 by each one of those terms that are on the outside. So it's still going to be 5 raised to, now we're going to distribute the 2, multiply it by the 3x, we get 6x. Multiply it by the 2 and we get a plus 4 up as our new exponent. From here, we now have the same base on both sides. We're allowed to drop those bases and set the 2x, that exponent, equal to the 6x plus 4. From here, we've got a nice linear equation. Shouldn't be too bad to solve down. Let's go ahead and move the 6x over to the left-hand side. This will give us negative 4x's on the left-hand side and positive 4 on the right-hand side after we cancel out those like terms. So with negative 4x equals positive 4, the solving down simply needs to be divided by negative 4. And we're going to get x equals negative 1 as our solution. Now on the second one, what we want to do is rely on the formula. We want to aim for 2 as our common base on both sides. But the formula we really want to look at is if we have the nth root of anything raised to the m power, you can rewrite this as x raised to a rational exponent, the m over n power. All right, so on ours, we can't really see the 2 out in front, but because it's a square root, there's automatically a little 2 as our index on that radical. And the 2 is raised to the first power. Again, we usually don't write that 1 there, but it's known that it's 2 to the first power underneath there. So now we have 2 to the 5x on the left-hand side. The right-hand side we can rewrite as 2 to the 1 over 2 power. All right, at this point we have the same base on both sides. Let's go ahead and drop the bases and set the exponents equal to one another. And we can solve this down by getting rid of the 5 by either dividing both sides by 5, or equivalently, we can multiply by 1 over 5. And I like doing this because we already have the fraction on the right-hand side. 5 multiplied by 1/5 is going to give us just x on the left-hand side. And on the right-hand side, because we have those fractions multiplied together, we can just multiply numerators. 1 times 1 is 1. And multiply denominators. 2 times 5 makes 10. So that's our solution there. I will give you one alternative way you could go ahead and find the solution here. Instead of rewriting that square root as a 1/2 as an exponent, instead, another option would be if we want to get rid of our square root, we could simply square both sides from the beginning. Where that would put us would be we would combine our exponents on the left-hand side by multiplying, right? 5x multiplied by 2 would make 10x as our new exponent. And we would just have a 2 raised to the first power on the right-hand side, if this is easier to see. So now we have 10x, dropping the bases, setting the exponents equal to each other. 10x equals 1. And to finish this one up, you would divide both sides by 10. And again, we would get back to that x equals 1/10. So 2 different ways to get that same answer on that one with the radical. Hopefully this helps out as you're working on solving exponential equations. Good luck.